Dan Kenning here. Tonight's lesson is on the Ampere-Maxwell Law. Essentially what the Ampere-Maxwell Law describes is that you will get changes in the circulation of a magnetic field for one of two reasons. The first being changes in current in a wire, and the second being for changes in the electric field that is circulating through some enclosed surface around that. So for some inspiration for kind of a down-to-earth example, I was digging around in my utility room and found this section of tubing, of hose. It's just real thin PVC hose meant for ice makers or water filters, things like that. And so let's take a look at the two components. What might change what this does? That represents the changes in the circulation of the magnetic field. We could change a couple things about this hose. The first thing that we could change is, well, the current through it. Right? I could run some water through it. I could run a little bit, or I could run a lot. And by changing how much water I was running through this thing might want to expand or stretch out more, or possibly not as much. And that could represent changes in the curl of the magnetic field, as we talked about before. So maybe that one's pretty obvious, but what might not be as obvious is changes in the electric field. As you might realize, if I would, for example, change the direction of this, or all of a sudden turn the water on full blast, a lot of water would go through really fast, but then it would slow down as the hose filled up and all the air drained out. And that would also cause changes in the shape of this. It would also cause changes in the circulation of the magnetic field, but for a different reason. So hopefully I've been able to explain to you that changes in current, the amount of water, but also just something intrinsic about itself, representing changes in the electric field due to changes in the magnetic field, due to changes in the current, can also cause changes in the surrounding curl of the magnetic field.